So I'm gonna switch to my browser. I'm gonna put it into full screen mode. Okay, this page is what we call dashboard. So basically, after you log in your portal, web portal, this is the first page you hit. So this is more like a single glass pane view where you can monitor the health status of your data center. So sitting at the top, there is the timeline. Obviously, horizontal line is time, but vertically it can be divided into 5 rows. Each row covers one aspect of your data center. From the top down, it's application performance, CPU health, memory health, storage health, and network health. As you can see, there's a timeline, there's a time slider on the timeline, which you can move around, right? You can select different time period. And once you change the time period, everything below the timeline got refreshed to reflect the data center health within that time period. So there's 6 widgets below the timeline, including application performance, network health, CPU health, memory health, storage health, and application server alarm widget. Let me expand one widget to explain the detail of the color wheel. Let me choose CPU health for this time. So as you can see, we'll structure your infrastructure in this way. In the core, at the core, it's your data center. And going outward, it's cluster layer, host layer, and VM layer. So on each layer, as you can see, there's multiple slices and segment. So each segment represents one entity on one layer. So next to the color view, we provide you the table view as well. So there's VM table view, host table view, and cluster table view, right? In each table, you can see all the statistics of the VM, of the host, of the cluster. So you can sort by any row, any statistics. So let me close it. So go back to the dashboard. So the first thing I want to show you is how Willa can help you to quickly identify the application problem, right? As you can see, I moved my time selection on this suspicious time period where the CPU health is pretty orange, right? You wonder whether my application performance got impact or not. Willa can let you know the answer right away. And over here, as you can see, on the application performance color wheel, everything else is green except this two hotspot. As you move your mouse over to the hotspot, you quickly realize a VM called Oracle 11G N2 is suffering from the application performance issue. So basically, the application performance time is too long. And as you can see, there's 2 services running on top of this VM: Hadoop HDFS, Hadoop MapReduce, and MySQL. So luckily, the Hadoop service is performing very well because we light them up as green, but MySQL is suffering, right? Application response time is over 1 second, which is pretty bad.
Hey, Roger, this is one question from the audience, that is to ask, how did Willa find out MySQL is running on this virtual machine?
Because as I mentioned before, we have VST deployed in your vSwitch. So VST do the deep packet inspection, and from there we can identify the protocols is running on the protocols running on which VMs, and by measure the application response time, we know how bad and how good this application is performing.
So it is deep packet analysis for application classification and response time. This is all automatically discovered.
Yeah, everything is automatically. We do the auto learning. We build up the auto baseline. Because we have all the statistics about application response time. We know when it's getting better, when it's getting worse, and based on that, whenever it's getting worse, we light up as orange or yellow or red, based on how severe it is, right? And also one thing I want to mention, right? Because Wheeler can quickly help you. On the top of that, Wheeler can also help you to identify the root cause, infrastructure root cause behind the application performance issue. So let me show you how to do that. So once I focus on this VM, which is pretty bad, right? My SQL service got impacted. One click on this MySQL service, we bring you to our root cause view. Here is the place we show you the correlation between application performance degradation and infrastructure problems. So as you can see on the top, there's two trending chart. The first one is application response time trending chart. The second one is the transaction volume trending chart. As you can see, the application response time right now is 100 and 900 milliseconds, which is way above the baseline. That's why the bar is so red over here, right? Of course, there's something wrong, right? You want to know what's the root cause. And here in the middle, we'll let you know which aspect of your application, of your infrastructure is the root cause. Here, as you can see, CPU health, the probability score is 100%, which means the correlation is very strong. And you got nothing wrong with your memory health, storage health. You have nothing wrong with your dependent service and network performance. So basically, the CPU health is the problem, right? By reading the text, you know the root cause is about the CPU contention on the host, on the cluster, right? Will allow you to drill down further to validate this conclusion. So just one click on the CPU health window, you go to the next layer. As you can see over here, we lay out the CPU statistics like CPU ready, CPU usage, CPU megahertz at all three layers, including VM layer, host layer, and cluster layer. So the background color draw your attention right away, right? As you can see over here, the CPU ready at CPU at VM layer, host layer, and cluster layer are all red. And the number is over 40%, which is very bad, right? Which means your VM is suffering from the high CPU ready. Basically, it's waiting for the CPU resources to be released by somebody else, right? And also, you can see the CPU's usage at all three layers. You quickly realize the CPU usage at VM layer is not high at all, but the CPU usage at host and cluster layer is as high as 95%. So you got a clear picture about the CPU contention issue on this host and on this cluster. The natural next step is to find out, which VM are fighting for the resources, CPU resources at this moment, right? One click on the host usage bar, you can see that information very quickly, very clearly. Here, after I click the bar, all the VMs who are fighting for resources is show up in the list. As you can see, there's a lot of VMs fighting for resources and pushing the CPU resource usage to be very high on the host level and cluster level. So over here, who's the major heavy user of your CPU resource, and what's your next step to do the troubleshooting. To find out what kind of transaction is being impacted by the CPU issue, will also allow you to do so. Over here, as I go back to the previous view, at the bottom, there's the section called worst transaction. Here is the another piece of information VSD collects, right? VSD can collect all the transaction information, for you to do more troubleshooting. Here, as you can see, Willa provide more detailed information about the transaction, being impacted by the CPU issues in this case. So we let you know who's the client, who's the server, what kind of service it is, and the detailed content of the request and reply. So the application guy, sometimes can join in to get more detail about the application, about the transaction, so he have more clue and insight about the root cause of the problem. Imagine if the root cause is not about infrastructure. The root cause may reside in the application itself. So application guy can use this information to getting closer to the root cause. Let me get back to the dashboard again. So we just went through the whole workflow, right, from the application performance degradation to infrastructure root cause. And actually we allow you to do it in another way around, right? For example, if you are a infrastructure operator and who really focused on your CPU health, and right now your CPU health lit up as orange, and you want to dig into your CPU health to find out whether the CPU health impact your application or not, right? That's another workflow you can do with Wela. So here, let me show you how to do that. Let me expand CPU health widget again. I sort by health score, so the worst VM show up on the top. By reading the text, you quickly realize all those red guys are suffering from the high CPU ready. And as an infrastructure administrator, you wonder whether the CPU ready impacting your application or not, right? And you can move your mouse over to this VM one by one. So as you can see, this VM Oracle 11G-N3, the CPU ready is very high, but luckily all three services are performing well in this case. So which means, yes, you have some CPU issue on this VM, but you don't have to do you don't have to address it as urgent as the other one, because as you move your mouse to the next VM, Oracle 11G-N2, and in this case you realize my SQL service is impacted by my CPU issues. So you realize this is the issue you really need to quickly address to alleviate the application performance issue. So it gives you a more insight about how to evaluate the severity of your CPU issue, of your infrastructure issue, and from the application perspective, right? Next, I'm going to go through other screens and views to show you how Wela can provide you the full stack visibility of your data center. The first view I'm going to show you is application analysis. So here, as you can see, Wela can draw the dependent service map for multi-tier applications. In this case, as you can see on the front tier, there is the VM called app load balancer. So behind it, it's a WebLogic server, right? Behind the WebLogic server, there's the bunch of your Oracle database and MySQL database. So the beauty of this chart is you can quickly figure out where is the bottleneck of your multi-tier applications. In this case, Oracle 11G-N2 light up as red. So once you move your mouse over to it, you quickly realize it's because your MySQL service is suffering from the long application response time. So from here, you can also drill down to the root cause analysis view again. So I don't have to repeat over here, but you got the point, right? So another thing I want to mention is this view also allows you to monitor the topology of your applications. So one of our customers really like this picture, really like this graph. He create 6 topology maps and project them on their big TV screens. And they switch on the real time, so he can pay attention to the structure topology of the applications. So whenever the topology got changed, he quickly realized, right? That really empowers him to do the troubleshooting proactively, right? Instead of waiting for somebody to complain. So the next one is network analysis. So here, the first page we show you is the flow analysis view. So over here, you can quickly identify what kind of applications and protocols running in your data center by looking at the classifier, the right columns, right? Very quickly, you know what kind of application and the protocols is running. And by tracking the ribbons, you know where the traffic is coming from, right? From which VMs, from which pro group, from which DV switch, from which host. And as you may notice, on the top, the time matrix got changed, right? Right now, we draw the trending chart on network transaction volumes. Here, you can quickly focus on the suspicious time period from the networking perspective. As I focused on this plateau, you realize somebody is running the iPerf traffic at this moment, which pushing the traffic to be very high at this moment. And again, we use color to draw your attention to the problematic VMs from the networking perspective. So once I move my mouse over to these orange VMs, as you can see on the tooltips, there's a lot of virtual packet job on this VM, right? Something wrong on these VMs. And also, you know how those application network issues distributed across different applications. Right? For example, on these VMs, there's HTTP, there's MySQL, and if you find out there's some networking issues on this application, we'll also allow you to do the packet capture. Here, next to the name, service name, you can quickly click the icon, and all the traffic filter on this service, filter on this VMs, gonna be forwarded to a predefined Wireshark VM or a GRE capable device in your environment. The next graph I'm going to talk about is network conversation views. Here, we'll draw the top 100 VM to VM link in your data center. As you can see, once you highlight a ribbon, the widest one, right, which means this bandwidth, the traffic between these two VM is the heaviest, right? So you quickly identify, which link are the heaviest user of your network bandwidth. There's another way to illustrate this VM to VM cross-talking view. We call it Sankey view. So the concept is similar. And if you want to filter, to do the live capture and filter by this link, we easily allow you to do so. Right? By click the links, you see the start capture option. Right? Very quickly, the traffic filter, the traffic gonna be forwarded to the Wireshark VM or GRE devices filtered by this VM to VM link. One thing I want to mention about the flow analysis view. So one of our customer, Samsung, their networking guy really like this view. They use the view, they use this view to quickly identify a imbalanced design of their applications. So basically, they identify one web server which is having 132 gigabyte memory within 4 hours, right? Which is more stressed than its peers, right? After the networking engineer showed this view to their CIO, the CIO basically said, okay, we got a design problem of our applications. So quickly, they address the problem and everybody is happy. The next one I'm going to talk about is the CPU analysis view. The first view is the circle packing view. So we illustrate your CPU resource allocation and usage in this kind of circle view form. So as you can see, the biggest circle is your data center, right? Inside your data center, there's two smaller circle, which is two cluster, and inside each cluster, there's several hosts. And in each host, there's a bunch of small bubbles, each bubble representing one VMs, right? As you can see on the top, the time matrix right now reflect the CPU's ready time trending chart and CPU usage trending chart for you to easily focus on the suspicious time period. For example, this time period, the CPU ready is so high, right? What's going on there? But once you focused on there, and everything got refreshed. And we use color to draw your attention, right? For example, once I focused on this red circle, which is a VM called Oracle 11G N2, and the circle is so thin because the usage percentage is not high at all. Why it's so red? Because the CPU ready is as high as 39%. And whether it's impacting your application or not, yes, in this case, the MySQL service got impacted, right? That's why we let it up as red. Also, you can drill in further by clicking the MySQL service. Then you go back to the root cause analysis view again to show the correlation between application and the infrastructure. So I don't need to repeat. Let's keep moving forward. Another way to illustrate your CPU resource is tree view, right? As you can see, multiple layers. Production is the data center layer, and behind it is two cluster, and under each cluster there's two hosts, and you can expand the host, right, to see all the VMs. And the Willa do more than other infrastructure monitoring too, because we always link the infrastructure with your application. So as you can see, under each VMs, we show you the applications running on these VMs, right? And once you focus your mouse on the VMs, you know how those applications are performing in this moment. Memory analysis. So basically, it's a similar as CPU analysis. We got circle packing view, we got tree view. Also, we have the alarms, right? The alarm, we got infrastructure alarm across CPU, memory, and storage. Once you expand the time selection, you will see some alarm popping up, right? So for memory case, we're tracking the CPU swap weight, we're tracking the active usage. Based on that, when everything got worse, we send you alarm to draw your attention. Storage and analysis is another very useful view. So here, let me change the screen a little bit. So on the top, the time matrix right now is tracking the rewrite latency and rewrite IOPS, right? For you to easily focus on the interesting time period. Once you focus on that, the chart below the timeline got refreshed, right? Here, by tracking the width of the ribbon and the bar, you quickly realize which VM, which host, which data store is the heavy user of your IOPS resources at this moment. Also, we use color to draw your attention to the problematic VMs, host, and data store who are suffering from the long rewrite latency, right? Once you focus on one VMs by reading the tooltips, you know this guy is suffering from the rewrite latency and high rewrite IOPS.
Roger, there's a question from the audience about storage. The question was, with the graph, it looks very good. You can see your storage performance. The question is, do you support all kinds of storage devices, NetApp, EMC, or iSCSI? What are supported and what are not supported?
Actually, we support all mainstream, storage, because right now, what we are looking at storage is within the virtualization environment, right? No matter what kind of storage, physical storage you are using, Willa can collect the statistics, can tracking the trendings, can trigger alarms and link to application analysis. So basically, all the mainstream physical devices we are supporting.
So mainstream meaning everything that VMware support, or what is mainstream? So is it as long as it hook up to VMware, then you can support it, or?
Yeah, as long as it can hook up with VMware, and we can support that.
Thank you.
The next screen I'm gonna highlight is Stats Browser. So here's the place. You can quickly filter by one entities, no matter it's VMs, it's cluster, host, right? And then we'll group all kinds of statistics on this entities. For example, we show all the storage statistics, we show the memory statistics, CPU statistics, everything. So here is a good place for you to validate the conclusion, to correlate the data by yourself, right? For some data geeks who really want to do this kind of lab work by themselves, right? They can do so over here. Another thing we have is reporting functionality. Right now, we provide on-demand report and schedule report. So gradually, we are enhancing our report by enriching the content of the report. So far, we support 4 report types: application performance, VM resource, host resource, and service performance. Critical resource view is the next thing I want to talk about. So imagine you have over 100, 200 VMs, and for this time you really want to focus on maybe just 5 VM to do troubleshooting, right? We'll allow you to do so by creating a VM group, right? You easily can drag and delete one VM into this group, and the time matrix on the top gonna reflect the health status of this group. So under each VM, you can see more detailed informations like the dependent service map of these VMs, right? What kind of service is running on it, whether it's performing good or not. And you can even change the threshold on this VM, right? Because we are tracking all those kind of key statistics on this VM and trigger alarm and change the color for this VM, right? If you want to change the threshold, you can jump in here to do the threshold adjustment. Alarms and also the usage. We show the trendings of all key statistics, and we show you the resource capability of this VM. So you don't have to jump between different platforms, different tools to collect information. Basically, we'll group everything, group all the related information for this VM to do the troubleshooting or the monitoring. The next view I want to highlight is VST configuration. Because as I mentioned, to allow VELA to monitor everything in your data center, you basically need to deploy VST on every host, on every virtual switch. So VELA provides you this user-friendly UI to do so, right? You don't have to rely on Hyper-V, rely on vSphere to deploy many VSTs. Just come to this page, one click on the install, and just fill up the necessary information. Click apply. Within 2 to 3 minutes, a VST gonna become up and running on this vSwitch, on this host. And later, if you want to delete, reconfig, restart, all kinds of operation you can do on this VM very easily. Let me switch back to dashboard. I almost go through all the major pages and functions of VELA. So I'm gonna stay here for some questions. So maybe you guys can raise hand or submit your question in the question check box on your control panel of the WebEx.
Hey Roger, there's one question from the audience that asks you to share maybe one customer usage scenario, how maybe 1 or 2 of our customers are using our solution to address what issue, and what's the usage scenario or troubleshooting scenario, if you have anything to share.
Yeah, I do want to share one story. It's from the largest reseller. Chachi also mentioned in his slides. It's the largest Nike reseller based in China. Its market is the whole Asia area. So it's a large company, and the VELA helped them. What VELA helped them is to narrow down their root cause of their application performance very quickly. It turns out the root cause is residing in their data store, but they don't know that. They're suffering for months, for even years. They don't know what's the reason. But after install VELA, within 2 to 2 hours, they quickly know the data store is the problem, because their data store. Maybe I can share one screen to you. Sorry, I have to switch to a different place. So basically, this is a picture of their storage analysis. So as you can see, they have so many VMs, so many data stores in their environment. But after install Villa for like a couple hours, we use color to draw their attention. So basically, all the red VMs are attached to three logical data stores, and all three logical data stores is attached to a out of date physical devices. But they never realize that, right? Use Villa, they quickly identified the problem, and after addressing this problem, everything, all the data store, all the VM, turn green. So they are happy about the result, and they are really satisfied about Willa.
Okay, Roger, thank you very much. I think that's all the question that I have from the audience.
Okay, so let me switch back to the slides. So since we finished the Q&A, let me quickly go through the summary slides. So Chachi, you want to talk about the summary and close this webinar?
Great, great. So before we conclude, just a quick summary of what we talk about today and what the value that we've been providing to our customers. So again, thank you for your patience and then for Roger's exciting demo. And so just a quick summary, how are we different than all the tools that you might have considered or maybe already own, right? So there are so many tools on the market and on your tool belt maybe already. What we provide very differently and distinctively what you have and what's available from the market is be able to provide the application level visibility for the IT staff in the infrastructure layer. And we are achieving so, as you can see in our differentiation column, without having to deploy any agents. So because typically in the IT staff, you own the infrastructure, but you don't get the luxury to deploy agent into your application. Therefore, that's your biggest challenge of gaining application visibility. With Willa solution, not only we don't require you to deploy agents, we offer you application visibility. You've seen Roger demonstrated application topology, application classification of what applications running, and also application performance to alert you to the application level issue. So we are really empowering the IT staff, managing the IT infrastructure with full stack visibility. And with that visibility from application all the way down to your infrastructure, you are able to monitor the entire data center without any missing link. And also with the color coding, with the dashboard, everything is under surveillance, right? And you can really see the performance visually clearly on your dashboard and being alerted at all level from application again down to infrastructure. And lastly, but not least, is that troubleshooting is actually very quick. You can do troubleshooting very quickly. And I do see one person raising question asking for, so I am going to unmute and then to allow active conversation. So Mr. Sanchez, do you have a question to ask?
Yes, sir. Good afternoon. I am talking from Mexico. So I want to know which requirements we need in a server in order to install the Willa software.
Great. So the question is, what are the installation requirements for each individual server to deploy, for example, the packet capture and the deep packet analysis? So maybe Roger will flip back to the architecture diagram very quickly to answer the question. So again, the question is, what are the server requirements for all these components? Let's answer the question completely. So, Roger.
As you see on the architecture, right? The first component. Sorry, let's jump to different. The first component we deploy VST, right? So the resource footprint of VST is very small. So it just require one vCPU, 2 GB memory, and 2 GB disk, right? This is the smallest VM we deploy in your data center. And second is VIC, Virtual Information Controller. So this is the bigger VM, but the resource-wise, it's just double the resource of the VSTs. The largest component in terms of the resource is UMass, but it totally depends on which way are you gonna go, right? If you choose Willa Cloud, you don't have to spend any resource on this component. But if you choose to go with on-prem, this is the biggest component you have to deploy in your data center. So by default, the resource requirement for UMass, if you choose on-prem, is 4 CPU and 32 GB memory and 500 GB disk.
This is a virtual appliance. This is not a physical box that we require.
Everything I mentioned is virtual machines, not physical device.
Okay. Mm-hmm. Thanks.
Thank you for your questions. Let's see if we got any more questions from the audience. Okay, I think we're good. So, in conclusion, let me go to the conclusion slide. So you probably seen already what Roger just demonstrated, how from our console you can see each individual virtual smart traffic tab he calls VST that can very easily be deployed. As a matter of fact, our deployment for proof of concept typically takes about 30 minutes to 1 hour, and we would actually welcome anybody who wants to try to either go to our website, as you see on the screen, www.uila.com. Just click on online demo to try out our live demo. In that case, you can just exercise everything that you've seen on screen today just through a easy web interface that's actually live. You can navigate and kick the tire and run our application there just to experience the user experience. Or you could go to free trial button, just click on free trial and then do an installation on your own lab or production environment. We are very, very safe because we are not inline. We're not going to disrupt your normal workload. And Roger and our team are very happy to help you through the process. The moment after you registered on our website, you'll be sent automatic deployment instruction. You can deploy it all by yourself, or we are more than happy to help you and do it along with you. As long as you give us 30 minutes or to an hour of your time, we can get it up and running in your lab environment. So with that, I would first of all thank you for your time and attention for our demo today. And please do try it out, our live demo, or do even better, do a free trial in your own environment with our support. We're more than happy to do that. Contact us at sales@willa.com. Thanks again for your time and your attention. We wish you a very wonderful day.